In number 24, we are going to solve for the extreme values of the function y equals 1 over x squared minus 1. This can be rewritten as x squared minus 1 to the power of negative 1. First, we will take the derivative. So we pull the negative 1 into the front, leave the original function, and then lower the power by 1, making it negative 2. We will then tack on our chain piece, which is 2x. This can be simplified as negative 2x times x squared minus 1 to the power of negative 2. We can then rewrite this as negative 2x all over x squared minus 1 squared. Looking at the denominator, we see that plugging in a 1 or a negative 1 will result in a 0 on the bottom, making the derivative undefined at x equals negative 1 and 1. Looking at the numerator next, we set it equal to 0 to find where the derivative is 0. We get x equals 0, so the derivative is 0 at x equals 0. So we now have our three critical values of negative 1, 0, and 1. We will take these values and plug them into the original equation to see if they are maximums or minimums. After plugging them back in, we see that the equation is also undefined at x equals negative 1 and 1, so there must be an asymptote at those values. We also see that we get the point 0, negative 1, so there's either a maximum or minimum at this point. Checking our work on our graphing calculator, we see that there are vertical asymptotes at x equals negative 1 and 1. We also see that the point 0, negative 1 is only a local maximum because the graph extends to positive and negative infinity. The point 0, negative 1 is a local maximum because the y values slightly to the right and to the left of it are smaller than the point itself. So the only extreme value of the equation y equals 1 over x squared minus 1 is a local maximum at the point 0, negative 1.